We are discussing today the physical quantities and its types. First, what is the physical quantity? Physical quantity is actually those quantities which can be measured. Whatever can be measured or whose reading you can take, that comes the physical quantity. For example, length, time, mass, these are physical quantities because they can be measured. But those are not physical quantities which cannot be measured. For example, you cannot measure love, you cannot measure any good act, any act of goodness or any cruelty. You can't measure. You cannot measure the beauty. So these are non-physical quantities. We in physics are concerned with the physical quantities. Now physical quantities are of two types, and those physical quantities are of two types. Physical quantities are of two types. One are the scalars and other ones are the vectors. What are the scalars? Scalars are those quantities which require magnitude and a unit. Now what is the magnitude? What is the unit? For example, if suppose speed is 5 meters per second, then this 5 meter per second, this one meter per second is the unit and this 5 is the magnitude. So scalars require only magnitude and unit. I will say what are scalars? Those physical quantities which require magnitude and unit. So those are the scalars. The proper definition of a scalar is those physical quantities which require magnitude and unit. For example, there are so many quantities: length, distance, time. Actually, all base quantities, 7 base quantities are scalars: time, mass, current, speed, power, energy, work, etc., etc. These all quantities are scalars because they do not require a direction. But what are the vectors? Vectors actually have the magnitude plus unit plus direction in space. The word space is must. If you do not say space, then there are at least two physical quantities I know which have the direction, but that direction not in space, and they are not regarded. Those are not regarded vectors. For example, time. Time goes from past to present to future, but it cannot be expressed in space. It has no direction in space. Direction in space means either the direction along x-axis, y-axis or z-axis, or in the north, west, east, south directions. Geographical directions are the angles with the x-axis, coordinate axis. Or I can say the vectors are those which can be expressed in I, J and K form or the components, at least in 3 dimensions, at least in 2 dimensions they can be expressed. So those are the vectors. So they can be expressed in 1 dimension also by just assigning the plus and minus sign. But actually direction in the space means direction of the x-axis, y-axis or z-axis. Similarly, the current. Current is another quantity which has the direction, but that direction is not in space, so that is not a vector quantity. I will define, suppose I will say it is 5 meters per second towards south. Now this is clearly velocity. Here 5 meters per second is just the speed. Here 5 meters per second towards south is the velocity because it has the direction in space. This meter per second is the unit and this 5 is the magnitude. Now I define vectors as those physical quantities which have magnitude unit and direction in space. Now, suppose for example, there are a few examples, displacement. Now see, distance is a scalar, but displacement is a vector. Displacement, then force, weight, velocity. Speed is a scalar, but velocity is a vector. Displacement, force, weight, velocity, acceleration, momentum, of course a linear momentum, impulse of a force, moment of force, etc., etc. These are some examples of the vector quantities. So I say scalars are those quantities which are the magnitude unit, vectors are those quantities which are the magnitude unit in direction space, and similarly suppose length, distance, time, mass, current, speed, power, energy, work, these are the scalars. Displacement, force, weight, velocity, acceleration, momentum, impulse, and moment of force are vectors.